In this demo, I will show you how to use TLS on AWS ELB. The first step before we can enable TLS on our Elastic Load Balancer is that we need to create an SSL certificate. In AWS, you have the AWS Certificate Manager. And this certificate manager allows us to create a new certificate that we then can attach to our load balancer. So this is the AWS Certificate Manager. You need to make sure that you are in the correct region. I'm here in EU West 1. And then I'm going to provision a certificate. So I'm going to click Get Started. I'm going to request a public certificate. And then I will use my domain name that I'm hosting in Route 53 because that's easier to then add the host name. I'll call this one Hello World. And then my domain name that is hosted using Route 53, Kubernetes New Tech Academy. I click Next. I will choose for DNS validation. Choose this option if you have or can obtain permission to modify the DNS. This is the easiest way. You can also choose for email validation, but then you have to make sure that your email addresses work. So DNS is the easiest. I'm going to click Review. Hello World, Kubernetes New Tech Academy. All correct. Confirm and request. Pending validation. So I need to add these records first. So this is the name, it's type C name, and this is the value. And because I have Kubernetes New Tech Academy hosted on Route 53, I can click this button, Create Record in Route 53. You will only see this button if this host name, Kubernetes New Tech Academy in my case, is hosted on Route 53. I click this button and then I click Create, and then it will create the records for me. So if I have a look at services, Route 53, open it in a new tab. The DNS record was written successfully to your Route 53 hosted zone. So let's go to my Route 53, hosted zones, Kubernetes New Tech Academy. And then here I have this C name that has been added. If you don't have Route 53, you have to add this manually yourself. So name, C name, and then the value. This will take some time to validate. And then after maybe 5 to 10 minutes, maybe even 30, you get status issued. This is the ARN. So this is the ARN that you could then use in your YAML file. So this is a unique ID that you need. So let's create our load balancer. In my Kubernetes course GitHub repository, I have a directory ELB TLS. And here I have two files. I have the Hello World YAML file that just contains a deployment, one that we used earlier already. And then we have the Hello World service. And here I'm going to use these annotations. So the first change I need to make is this one. It's a cert. I need to here paste my ARN that points to the certificate I just created. The backend protocol is HTTP because the communication between the load balancer and my pod is HTTP. My Hello World deployment is not on HTTPS, so this still needs to be HTTP. The SSL port that I want to use, this is the listener of my load balancer, is 443. So port 80 will not use SSL. So it's important to set this, otherwise Kubernetes will just put SSL on every single listener. I also enabled connection draining, and connection draining is 60 seconds. So if a node gets deleted, it will keep the connections still live for another 60 seconds. And I also add two tags, environment equals dev and app hello world. These will be tags added in AWS. Then I have two ports that will be added to the load balancer, an HTTP port on port 80 that will go to my deployment, and an HTTPS port on 443 that will also go to my deployment. So it will connect to the Node.js port of my Hello World app. So it's encrypted to the load balancer, and then TLS is terminated, and then it will go over plain text to my pod, because then I am in my internal network. I don't need SSL or TLS in my internal network. So that's it. I save this. I do kubectl create of hello world.yaml and of my hello world service.yaml. And this will then create a new service that you can then get the hostname of using OWhite. And now that we have this hostname, we should also add the DNS name Hello World Kubernetes New Tech Academy so that we can connect on that hostname rather than this one. Let's do that first. So I'm going to go back to route 53. Let's go to route 53. Hosted zones, my Kubernetes New Tech Academy, and let's create a new record set. It's going to be Hello World. It's going to be an alias. You can also use CNAME, but alias is easier because this will just show us the ELBs that are available. This is my ELB. Let's check that in another window. Services, EC2. And here we have load balancers on the left. So we only have one load balancer. So this is correct. We do create. And now we have Hello World Kubernetes New Tech Academy that points to our newly created load balancer. So we now should be able to use this hostname, and they should then go to this load balancer here. Let's have a look at the configuration of the load balancer. We have two instances. These are our nodes. The master node is never used. We only schedule pods on the node itself. They are in service, that means that they are healthy. And then let's have a look at the listeners. We have two listeners, an HTTP listener on port 80, an HTTPS listener on 443. And this one uses our certificate. And then we also have our tags. There are some tags that are added by Kubernetes, and we have the tag app equals hello world and environment equals dev. So those we added. So this should all be working. Let's test it. Back to our terminal. kubectl get services OWhite shows us this host name. Let's test the HTTP connection first. Replies hello world. Let's try HTTPS. And this works, but it says certificate subject name Hello World Kubernetes New Tech Academy does not match target host name. And that's why we had to create this DNS name Hello World Kubernetes New Tech Academy, because this needs to match, because our certificate needs to match before we can use this. Curl of Hello World Kubernetes New Tech Academy shows us no warning and shows Hello World. Same if we do it over regular HTTP. So that's why we need this extra configuration. We need to use a host name, otherwise it will give us a warning. You can also ignore the warning. With curl, that's -k, and then it will still work. In a normal browser, it will ask you whether you want to proceed. So this is how you can configure and add TLS certificates on your load balancer, and then you can terminate encryption on your load balancer, which is a great way to manage your TLS and SSL certificates, because there's almost no management of this. AWS will manage and renew your certificates.